Greetings viewer, EricTheCarGuy back again with another RE video. This time this is a video response to the P0325 diagnosis that I did not long ago involving the knock sensor on this here Subaru. Several comments on this one, and most of them are focused to basically the use of my multimeter and the fact that it does not possess an auto ranging function, or it does but only up to a particular resistance. And I believe you're right on that. So what I thought I would do is I'd go back over, do a different ohm test on this and do a different ohm test on a new sensor as part of this video in order to respond to those questions, which, you know, great point. Yeah, I'm not perfect and you guys spotted something very important. So why don't we see if the factory Subaru procedure does have any merit as far as this concerns, because I absolutely know for certain that the knock sensor that I installed on this vehicle is good, since it's been about 2 weeks since I installed it and I've not seen the check engine light come back since. We have a known bad and a known good. We want to know the answers, so let's see what our resistance checks will prove out here. Let's start with the old sensor, or better yet, let's start with my multimeter, which it's very difficult to read this section on resistance, so I hope that you can see that a little bit. The setting that I put it on was here on the beep setting, and that's auto ranging. And for those of you wondering what kind of meter this is a Blue Point meter, which is made by Fluke. So pretty much they buy these from Fluke. So this in essence is a Fluke meter. But I was putting it on this auto range, just beep for continuity, and anytime you have continuity, it beeps and tells you basically how much resistance it sees. And in this case, I've got a little bit in my leads. But here's what all the fuss is about. And that's that when you put it on that setting, when I was testing this sensor, we'll just hook it in here for ground and bring it up here for the actual sensor, that even though I know I'm touching here and I can get resistance there, it's not set on the proper scale. In other words, the resistance here is too high in order for this to register on the auto ranging scale. So I tried it on different scales. This is 20 kilo ohms, and the measurement that we were looking for according to the book was 700 kilo ohms, so that's well above that. It's also well above the 200 kilo ohms. So here's 2 mega ohms, which is like pretty stinking high as far as resistance goes. Let's try that. Still nothing. And then finally, we have the final scale here, and I hope you can see that. That is the 20 Mega Ohm Scale. Let's see what reading we get when we do that. Once again, this time we are getting a reading. 2.42, 2.4 mega ohms, as I guess we could call that. So it's barely over 2 mega ohms, but still well above the 700 kilo ohms, which is the spec. So if we're doing resistance checks, the takeaway here is that we got to make sure that we have it on the scale. So if we're looking for a high resistance value, be sure to know your meter one to know what the auto ranging scale will cover, because obviously on this one it didn't cover that much. It didn't go through the full sweep. It only went up to the 200 kilo ohms, I suspect, as many of you pointed out. So let's go over to the car and check the sensor there that is known good. Okay, just to give you a quick recap of the setup, I am on the battery ground here, which basically goes over and grounds right there behind the sensor. The sensor is now unplugged, and I'm going to be checking from the sensor to the ground, this battery ground, to see what the resistance is. Okay, I'm going to start on the 200 kilo ohm scale. Well, actually there's no point in that because we're looking for 700, so I'm just going to leave the scale the same at the 20 mega ohms and see what we have. .54. Let's try the 2 mega ohm scale, see what we got there. 0.535. I'm just going to go down the scale and see how far we can go down. Okay, so 200 kilo ohms, it's not there. So it's actually 0.535, which if we're looking for 700 kiloohms, that's under the 700 kiloohms. So that sensor in essence tests good according to the factory spec. Okay, now we've got actual evidence that the factory testing procedure does have merit and that I needed to put the meter on the correct scale, because the auto ranging, I believe, as many people have pointed out, only goes up to 200 kiloohms, and we were looking for a reading of 700 kiloohms or somewhere thereabouts, I believe, in the original testing. Bottom line is, this will only check an auto ranging up to 200 kiloohms. So if you're on an auto ranging scale, and yes, indeed, this does have an auto ranging scale, I believe, up to those 200 kiloohms, it may not be enough if you're looking for more than that. So the spec in this case was 700 kiloohms. So there was some merit to the factory test that I had there. It's just that I was not testing it correctly. And this is something you've got to be aware of when you're doing these kinds of things. So know how to use your tools and know the specifications of something and make sure you're testing it correctly. Personally, I like voltage drops more than I like doing resistance checks. I used to do lots of resistance checks, a while back, and they are a useful test. However, I've just really gotten into voltage drops. I've just found those to be, at least for me personally, more effective than doing resistance checks. So that's why maybe in my mind I latched onto a voltage drop test, which both tests were valid. So now you've got two ways of testing a NOx sensor. And briefly, just very briefly before I go on about this, a lot of you wanted me to cut this sensor open to show you what was inside. And even though I believe this, I'm not gonna say that I know exactly what's inside here, but as far as my knowledge of NOx sensors, it's that they contain piezoelectric crystals. And those are crystals that they use in, like, say, microphones, things like that. And they produce voltage based on vibration. So the NOx sensor is basically like a microphone, and it's set up to produce X amount of voltage. Or it's set up to produce a voltage based on when it detects a certain frequency, a certain vibration. And I think when I was hammering on the engine, this needed a specific frequency. These are dialed in. These are made to detect a specific set of vibrations that could be possibly damaging to the engine, and it's set up to ignore anything else. Like I said, if you're driving down a bumpy road or there's something else that's knocking around or rattling around, you don't want this thing retarding the ignition timing on you. You only want it to do it during a specific window. So the engineers make these things to work within that window, and that's that. So I hope that brief explanation of the NOx sensor and also this testing that I just did with the meter on a different scale is going to answer a lot of those questions, because I think those are really great questions. So thank you for asking those. And I hope to see you on the next RE video. I am Eric the Car Guy. You can always visit me at EricTheCarGuy.com or follow me on Facebook, Twitter, and now Google+. And I'm going to close with, be safe, have fun, stay dirty, and test it. Make sure you test it. Or maybe it might be better to say, make sure you're testing it correctly. See you next time.